Can somebody confirm you can hear me?
Yes, I can hear you.
Thank you. Yep. In time. All right, before we begin, are there any questions? Did I finish this one? I think I did. All right, I'm not hearing any questions, so let's begin. See, I can get rid of that. And let's share my screen. I think we have a video, but there it is there. Not terribly useful here, but let's come to here. So today is November 4th, and we are supposed to be doing Lab 8, identification of gram-positive organisms. Let me remind you, your unknown work, you're supposed to be working on your unknown project, but your infectious disease project is due Saturday, November 8th, and that's this Saturday. If you haven't began working on it, you need to get permission or approval from me. I want to make sure that it's an infectious disease and one that's doable. There are a few projects I break up, like tuberculosis. I break into late stage and early stage tuberculosis. Others I divide by species, like malaria. I divide it by the species of plasmodium that's causing the malaria. So you need to get approval from me. If you do not get that approval and you're turning in a project, you probably turn in a project that two people are on, and I don't want that. And I'll also give you a 10-point penalty for not getting the project approved. All right, if there's no questions, let's begin Lab 8. Um, what was I supposed to talk about here? I was talking about the infectious disease project. Hmm. All right, Lab 8, identification of gram-positive organisms. We're going to be talking about gram-positive cocci, specifically Staphylococcus, Enterococcus, and Streptococcus, these three families of gram-positive cocci, as well as gram-positive bacilli, including Listeria, Clostridium, Bacillus, and Corynebacterium. There are some video clips in today's lab. There's a dichotomous key and some case studies. Let me show you the dichotomous key and the case studies. Out of the way. So if you take a look at the lab, week 7 lab, yeah, we're actually in week 7 of the term. Um, there's the lab module, and there's the worksheet for lab 8. We also have 8 case studies, and then one dichotomous key for working on Lab 8. Only use this dichotomy key for Lab 8. Do not use it for any other lab or for your unknown project. It's specifically designed for Lab 8. I thought about putting all of the case studies together in one file, and then you'd only have to open one file, but I'm glad I didn't, because this is the way the lead microbiologist sent Lab 8 to me. And One time in the past, I think it was case study 4 and 5, he sent me an update where he changed the case studies. And so I only needed to put in his reiterated lab 4 and case study 4 and case study 5. I didn't need to go in and change my entire document. So I'll keep it this way. And this dichotomous key, let's talk a little bit about that. Actually, I have it right here. So first you take all your cells and you're taking them by the gram stain. We're talking about gram-positive cells here. And then we're talking about gram-positive cocci and gram-positive bacilli. We're not going to discuss the bacilli, at least right now. We're going to talk about the cocci. So the bacilli are crossed out because when you look at them under the microscope, you're only seeing cocci. And by the way, you can say that cocci, cocci, cocci. What's the fourth way? There's a fourth way too. It depends where you are in the world, and I just gave up because people move around and I don't really care how it's pronounced. You can call it cockeye or coxy or cocky, whatever the fourth way is. I don't remember. Cocky, cockeye. Yeah, that's the two. Cockeye and cocky. All right. Then we look at the cockeye and we take a look at the catalase test. We have the catalase positive organisms over here. That's members of the Staphylococcus family. And then the catalase negative organisms, which are members of Streptococcus and Enterococcus family. We're going to cross out the catalase positive because it's catalase negative. Let me shrink this down a little. And then we do the hemolysis test. It's not stated here what it is, but it's alpha hemolysis, beta hemolysis, and gamma hemolysis. For the alpha hemolysis, we have Streptococcus pneumoniae and Viridian Streptococcus. So if it's alpha hemolysis, it's these two. And then you can do the optogen test to distinguish between Streptococcus pneumoniae, because it's optogen positive, or if it's optogen negative, it's the Viridian Streptococcus. For the beta hemolytic catalase negative cocci, there will be Streptococcus pyogenes and Streptococcus galactea. We do the bacitracin test and the CAMP test to distinguish between these two. If it's Streptococcus pyogenes, it'll be bacitracin positive and CAMP negative because Streptococcus pyogenes is sensitive to the antibiotic bacitracin, but it does not, it's not positive in the CAMP test, but Streptococcus agalactiae is bacitracin negative and CAMP positive. And then lastly, for the gamma hemolytic organisms, we're looking at the families Enterococcus and Streptococcus. We have two tests to separate these out. If they're biolesculin positive and SF broth positive, then it's Enterococcus faecalis. And if it's biolesculin negative and SF broth negative, it's gamma streptococcus. Any question about any of that? All right, I'm not going to talk about the catalase positives, but I will come down here and talk about what if it's a bacilli. So we have the gram stains, gram positive, then we have gram positive bacilli. You can separate them into anaerobes, Clostridium species, and aerobes. If it is an aerobe and if it produces an endospore, then it's a bacillus species. If it is endospore production negative, then it's Listeria species or Corynebacterium diphtherium. And you can split these two by doing the hemolysis test and then the CAMP test. If it's gamma hemolytic, it's Corynebacterium in that family. And if it's beta hemolytic, as well as positive weak, meaning it is positive but weakly so, in the CAMP test, then it's Listeria monocytogenes. Any questions about using this? All right. If the key does give you a species and you're putting in an answer, you should put in the answer, the species. But if it gives you only the family name is correct. You don't need to say the species because that applies to all members of the family Corynebacterium. Any questions here? That's how you use the dichotomous key. Only use this dichotomous key one more time, only for Lab 8 and for the case studies in Lab 8. Do not use them for the unknown project or for any other lab for that matter. All right, we have some video clips in this lab, and like I said, the dichotomous key and the case studies, the last two being provided in separate files in Canvas. And let me state that you could do the case studies by putting the information into an AI, artificial intelligence, and then getting the answer that way. If you do that, realize that your answer must be a bacteria mentioned in this lab. Otherwise, it's just wrong. I don't care how intelligent the AI is. We're talking about the material in this lab. And so the answer must come from this lab. And then the other reason for not doing the AI is you need to know how to do the case studies on your own for the quizzes and the final, because there will be case studies and the quizzes and the final. And if you simply use AI, you won't be able to answer the case studies on the quizzes, or you'll have a hard time answering them on the quizzes and the final. So you should at least do them on your own, and then you can use the AI to confirm your results in this lab. All right, the learning objectives of this lab. One, understand the principles and how to interpret the results for the CAMP test, the Bilasculin test, the SF broth test, and the optogen sensitivity test. And two, be able to use a dichotomous key to solve case studies involving gram-positive bacterial infections. Any questions about anything so far? All right. When specimens are received in a microbiology lab for a routine bacterial culture, they are inoculated on culture media that will facilitate the growth of common bacterial pathogens and then placed in a physical environment to support their growth. Microbiologists can use the colony morphologies and the gram stain to provide important information in the classification or beginning classification of the bacterial isolates. However, you will need further biochemical testing in order to identify the species. In this lab, we're going to talk about the CAMP test, the Bilasculin hydrolysis test, the SF broth test, and the optogen sensitivity test. Any question about any of that? All right, the first test we're going to talk about is the CAMP test. CAMP is an acronym for the three microbiologists who discovered the CAMP test, Christie, Atkins, and Munch-Peterson. In the CAMP test, we're looking at the amplified hemolytic effect that some beta hemolytic organisms have when they're grown physically near Staphylococcus aureus. What you do is you get a single streak of beta hemolytic Staphylococcus aureus placed down the middle of a blood agar plate, BAP being blood agar. And then perpendicular to that streak you put the test organism. So here, let me blow this up. I'm going to blow it up real high. I still need to get it higher. There we go. So right there, kind of a reddish color, is the Staphylococcus aureus streak, and you'll see a clear region around it because Staphylococcus aureus engages in beta hemolysis, totally lysing the red blood cells around the Staphylococcus aureus. Streptococcus pyogenes in all bacteria tested in the CAMP test engages in beta hemolysis also. And there you can barely make out the thin streak of Streptococcus pyogenes, and then it has a thicker region around it, which is from the beta hemolytic activity, where all the light red blood cells are lysed. What we do is we look in this region for the enhanced hemolysis, enhanced beta hemolysis of the CAMP test. Streptococcus pyogenes is negative in the CAMP test because it does not exhibit enhanced hemolytic activity when grown next to Staphylococcus aureus. Any question about any of that? On the other hand, Listeria is slightly positive in the CAMP test. Here's the Staphylococcus aureus and the clear streaking or clear hemolytic activity around it. And there's Listeria, the single streak. And you note right there a very thin beta hemolytic area around the streak of bacteria. And there we see enhanced hemolysis in this region of the Listeria growing next to the Staphylococcus aureus. So Listeria is slightly positive in the CAMP test. And then here we have Staphylococcus aureus with its beta hemolysis. There we have Streptococcus galactea shown there with a very thin beta hemolytic activity around it. And there we have very greatly enhanced hemolytic activity of the Streptococcus galactea when it is grown next to the Staphylococcus aureus. So Streptococcus galactea is positive in the CAMP test. It is normal to see an arrow-like appearance with a positive result. In fact, with Listeria, you notice it's also somewhat like an arrow. A smaller arrow, but a small arrow. I know why there's no further enhanced hemolysis in this region, and that's because the Staphylococcus aureus is lysing the red blood cells, and then the ingredients required by Streptococcus galactea are diffusing out into the agar to this region here. Beyond this region, there is no further diffusion of the ingredients coming from the red blood cells, and so there's no enhanced hemolysis in this region. I do not know why the point is somewhat like an arrow, but it probably has to do with the fact that the Streptococcus galactea has to compete with the Staphylococcus aureus, and why it makes sort of a point that way. Any questions about the CAMP test? Looking at enhanced beta hemolysis when the unknown is grown next to the streak of Staphylococcus aureus. The CAMP test only tests beta hemolytic organisms. So all of these, Streptococcus pyogenes, Listeria, and Streptococcus galactea, engage in beta hemolysis. We don't use the CAMP test on a cell that does not engage in beta hemolysis. All right, let's move on to the bile esculin hydrolysis test. The bile esculin hydrolysis test is used to differentiate Enterococcus that family from the Streptococcus family. What it is using is you have esculin, which is in the media, and if the organism can hydrolyze the esculin, it'll make glucose, which you don't need to know, and esculatin. Esculatin is a dark brown color forming a dark brown pigment, or actually black pigment. And if 50% or more of the tube is black or darkened like this, you consider the test bilesculin positive. On the other hand, if less than 50% of the tube is black, and usually it's no change in the tube is the same color, it is negative for the bilesculin hydrolysis test. An example of a negative species is the family Streptococcus. All members are negative in the bilesculin test. And then an example of a family which is positive is the Enterococcus family. All members of the Enterococcus family are positive in the esculin test. Any question about any of that? All right, the next test is the SF broth test. SF actually stands for Streptococcus faecalis, which is the old name for Enterococcus faecalis. Before they did DNA synthesis of the DNA of Enterococcus faecalis, they assumed it was a member of the Streptococcus family. And so it was grouped among the Streptococcus. And its old name was Streptococcus faecalis. Now we don't use it that, we call it Enterococcus faecalis, but we still call it the SF broth test. Any question about any of that? All right, the SF broth test has a carbohydrate glucose and a pH indicator. If the bacteria can ferment glucose, it will make acidic products in the fermentation, which will change the media from purple color to yellowish color. So this is SF broth positive, and if the color remains purple, meaning negative, it is SF broth negative. Enterococcus faecalis is positive in the SF broth test. The members of the family Streptococcus, I'm talking about the new members of the family Streptococcus, are negative in the SF broth test. All right, let's move on to the optogen sensitivity test. It's used to differentiate between Streptococcus pneumoniae and other alpha hemolytic streptococci. So you have to first narrow down your possible species down to the family Streptococcus, and then you do the beta hemolysis test. Let me blow this up so I can show you better. There. The off-white color is the bacteria colonies, and you can see around all of them, there is beta hemolysis, meaning a darkening of the agar. Come on. Can't move it. So this is streptococci, we know that, and it's alpha hemolysis. We then take some of these cells and streak it in this region of the plate, incubate it. Come on, let me shrink this down now. Incubate it. And if there's resistance to the antibiotic optogen, meaning you put the bacteria in this region, put a paper disc containing the antibiotic optogen on the plate, and then incubate it. If the bacteria are resistant to optogen, then the bacteria are alpha streptococcus, but it's not Streptococcus pneumoniae, because Streptococcus pneumoniae is sensitive to the antibiotic optogen. And to be sensitive, you have to have a zone of inhibition greater than or equal to 14 millimeters. So if it's less than 14 millimeters, it's actually considered to be resistant to optogen. But if it's 14 millimeters or greater, the zone of inhibition, then it is Streptococcus pneumoniae because it is sensitive to optogen, that antibiotic. Any questions about any of that? All right. Microbiologists utilize a dichotomous key describing which test should be performed and then illustrating how to arrive at a logical solution using the dichotomous logic, meaning a methodological thought process using dichotomous logic, where you take all species, split it down into two, like the gram stain, gram positive, gram negative, and then you can split the gram positive into gram positive cocci and gram positive bacilli using dichotomous logic. An example of using dichotomous logic is following this here, where we can do the gram stain. If it's gram positive, it's here. Gram negative, it's here. We're going to cross these out because our example is gram positive. Then you can split the gram positive and the gram positive bacilli and the gram positive cocci. We have gram positive cocci, so we're going to cross those out and then follow the gram positive cocci. We can then split them by following the catalase test. You have the catalase positive species, Staphylococcus, and the catalase negative species, Enterococcus, Streptococcus. We're not going to follow these because we're going to follow the gram positive catalase. Then you can do the coagulase test. If it's coagulase positive, it's Staphylococcus aureus. If it's coagulase negative, it's some other member of the family Staphylococcus, but it is not Staphylococcus aureus. Any questions about how you do dichotomous logic? All right. In this lab, you're not going to be physically performing any of these activities because everything we're doing is online. However, you will be held responsible for knowing how to perform and interpret them. You can view the following video clips on the SF broth test and the biolisculin test, as well as another video on the camp test here. Let me go to the worksheet now. And then fill in the table underneath number 2. So I've done the first example of the table for you. For the gram stain of both cocci and bacilli, the positive result will be purple for both gram-positive cocci and gram-positive bacilli. For the negative result, both will be pink. So all you need to do is write in purple or pink, and I've actually filled it in on the worksheet for you, but that's how you do it. And then give me the positive result for the Schaefer-Fulton stain for endospores, and give me the negative result. You can look up in an earlier lab what the positive result is and the negative result if you do not remember. Then give me the negative stain for capsules. What's the positive result looking like and what's the negative result looking like? It is possible to state it in 2 or 3 words, but if you need more space or you want to discuss it at greater detail, then you just need to enlarge the size of this cell. You can, in fact, enlarge the size of the entire table, but you may need to enlarge the size of that cell just by typing in there and then letting it expand. Give me the positive result for the catalase test where you add highly reagent hydrogen peroxide to the bacteria, and then give me the negative result of the catalase test. Give me the positive result for the coagulase when it's applied to rabbit plasma. So you put your cells in rabbit plasma. What's the coagulase result, a positive result, and what's the negative result for the coagulase test? For the oxidase test, what's the positive result here, and what's the negative result? For the CAMP test, what's the positive result, and what's the negative result? And for the CAMP test, you only need to know enhanced hemolysis and then no enhanced hemolysis. We're not going to split it into slightly enhanced hemolysis. For the bile-esculin hydrolysis, give me the positive result and give me the negative result. For the SF broth test, give me the positive result and give me the negative result. For the optogen sensitivity test, give me the positive result and give me the negative result. Remember, you can't just say zone of inhibition because it has to be greater than a certain size to be positive. Otherwise, it is negative. And then basotrace sensitivity test, we talked about that in an earlier lab. You can look it up if you need to, but give me the positive result here and the negative result here. We are going to talk about the basotrace sensitivity test in two of the case studies, why I've got it in here. All right, 3A, if you need help on understanding and using a dichotomous key, we have a little link here for you to follow and a little discussion here. And hopefully that'll help you work through the example if you need help on the dichotomous key. If you're perfectly comfortable with the dichotomous key, you do not have to do 3A. In 3B, we are simply listing the organisms that will be used to answer question 4. So there is no question on 3B. There's nothing you need to do. It's just listing the species under consideration for number 4. In number 4, we have 8 case studies. What you should do is go through the case study, interpret the results, and then write down your species, meaning go through your results on the dichotomous key, and then write down the species that the answer is in the dichotomous key, or if it ends at a family, go ahead and write down the family name for case study 1, and then for case study 2. Let me go and talk about case study 1. Oops, where do I have that? Here we go. I'm going to open it from my file on the computer because it'll display better than if I open it in Canvas. Case study 1. A 13-year-old teenager attended a week-long summer scout camp. Upon returning home, his mother notices a pustule beginning to develop in a spider bite on his arm. The area is warm to the touch and is becoming extremely painful. It's also kind of hard. When her son starts running a fever, she takes him into a walk-in medical clinic for clinical evaluation. There's the boy in the summer camp. There's the pustule on the arm. And then the routine culture and studies were done. Here we have the gram stain here. You need to blow that up to actually see it. See if I can blow that up. That's really blown up very large. Oh, come on. So there are the cells, the bacteria causing the infection. These large pink cells are actually the boy's cells. So you only need to look at the smaller cells. So tell me what the gram stain is as well as the shape of the cells. Let me shrink it down now. And then we grew the cells from the exudate on a blood agar plate. And there you can see the growth on the blood agar plate, and you can see the hemolytic activity here. And then they did the catalase test, where they took some bacteria here, put it on the slide, and then added the hydrogen peroxide to it. And here's the results of the catalase test. And then they took some bacteria, put it on the slide here, added plasma, got the results of this test here. Let me shrink this down even further. And then on test 3, we have bacteria, come on, growing on a mannitol salt agar plate. And the boy's bacteria, oh, come on, get out of the way, is growing on the left side of the dish. The right side is a positive control. This is mannitol salt agar. If you need to, you can find mannitol salt agar under week 5 lab of the unknown test, as well as we discussed it in some other lab. Anyways, that's the result of the bacteria growing on the mannitol salt agar. So write that result down. And then we have the NOVA bias and sensitivity test right here. Took the bacteria here, grew it up here, and then put the NOVA bias and disc on. And then you can see the results. And then the question is, what bacteria was isolated? And put that in the worksheet for case study 1 here. Oops, here, sorry. Let me briefly talk about case study 2, because I need to talk about the basotracin sensitivity test. Close that one down. Study 2, we have a 27-year-old female receiving prenatal care. Come on, move up. At the end of her last trimester, the physician orders a routine vaginal culture. Just as a routine, the woman herself is not exhibiting any signs or symptoms of an infection. The thyromartin tube has no growth. Lactobacillus, along with other normal vaginal microbes, were cultivated on blood agar plates. However, there were several colonies of interest. These colonies were streaked for isolation and then grown on a blood agar plate. Sorry, that's in there. And there's the growth on the blood agar plate. You can see the hemolysis right there. And there's the gram stain there. You can blow that up to take a look at the cells as well as the gram characteristics. Shrink that down now. We did a few more tests. We took the cells from the blood agar plate, put it on a slide, and then added hydrogen peroxide to it, getting this result for the catalase test. I shrink this down even further. We then took the cells from the blood agar plate and streaked them out on the plate here. And test 2 is, oops, sorry about that. Test 2 is the basotracin sensitivity test, which is not shown in this case study. But if you look at the case study number 4, case study number 2, it tells you test 2 is the basotracin sensitivity test. So give me the species isolated here. Oh, I forgot about the camp test. And then they took this bacteria here, streaked it there, streaked it, excuse me, that's Staphylococcus aureus streaked there, then streaked the unknown bacteria here for the camp test. And they saw this result in the camp test. And then answered the question, what bacteria was isolated? and put your answer in worksheet for case study 2 here. And then do that for case study 3, case study 4, case study 5, all the way to case study number 8. Any questions about this lab? If not, go ahead and start working on the lab. I will be here until 7:45 or the last student logs out to help you with any questions on the lab. I am here for your own reference, by the way.
I have a question. You don't need each like test answer, right? You just need like the final answer for each case study.
You only need to know the final answer, the
Okay.
species or the family causing it. You should, however, go through the dichotomous key, in which case you do need to write down somewhere the results of each test, because you have to use those test results to go through the dichotomous key.
Okay, thank you.
Okay?
Would you want to see the dichotomous like notes on our lab sheet, or should we just keep them for ourselves?
I'm not sure what you're asking for, so could you repeat the question and maybe explain a little further?
So we're using the dichotomous key to go through the case studies and writing down the test answers using the dichotomous key.
You need to use the dichotomous key to get your answer for this lab.
Right,
So you need to have the test results.
right.
You can write them down, I guess,
Do you
as
want
you're
us,
going through. While you're going through this, although if you have it online, you might be hard to do it. If you print it out, you can write it out. Test 3, write out the result here. Test 2, write out the result there. But you need to have it someplace so you can
okay,
go through the dichotomous key.
right. Do
You
you
don't
want,
need to turn it in, though, if that's what the
okay,
answer is.
yeah, yeah,
Yeah.
that's what I was asking.
Okay.
Thank you.
Sure, you're welcome. I'm here until 7:45. Last student logs out. If you have a question, make sure you ask it before the last student logs out, because I'm going to log out when the last student logs out.